Welcome to screencast number 2 on Chapter 21, New Renewable Energy Alternatives. We are going to continue talking about policy and investments and how they can accelerate our transitions. One of the things that I had wanted to mention at the end of the last screencast that advances in renewable energy have been tightly linked to the national, state, and local policies that encourage them and to the investment funding that flows more freely as a result. We have seen that global investment, and this includes both public and private, in renewable energy rose to about $244 billion in the year 2012. And that is nearly 6 times the amount that it was just 7 years earlier. So economics of renewable energy has been really erratic when we take a look at that. The technologies are evolving quickly. So what happens is the policies will then vary from place to place, and they can, as a result, change unpredictably. Industry has been very volatile, and they've been experiencing steep price fluctuations, even as far as bankruptcies of some of the most promising companies. They have seen bursts of rapid growth. There's because of the influx, and we are still learning how to apply policies to regulate these wisely. In 2007, Spain had adopted what they call feed-in tariffs. You read about them in the case study. And that were so generous. They were about 58 cents per kilowatt hour. And thousands of people rushed to sign up and set up for solar facilities because of this incentive. Within a year, Spain had increased its solar capacity 5-fold, which accounted for half of the solar power installed worldwide that year. The generous payments attracted a flood of unqualified contractors and speculators. So people that didn't know anything about the solar energy industry wanted a hand in this, and they wanted to be able to get money from it. So many of the solar plants were hastily built, poorly designed, and badly located. The government realized that many of these new plants would never be economically self-sufficient because of the way that they were built, and they very abruptly slashed the tariff rates. Critics of the government subsidies for renewable energy complained that funneling taxpayer money to particular energy sources is inefficient and can actually skew the market. Lost where I was going, sorry. So they had made new propositions to let energy sources compete in the free market. In 2011, a Nancy Fund and a Ben Healy dug deep into the data of the U.S. government's many subsidies and tax breaks for all energy sources from the early days of oil, which started in about 1918 through the present, and their report found 3 main findings. And this is what we're seeing on the screen right now. That oil and gas have received 75 times more subsidies than the new renewable energy sources. Okay, so nuclear power received 31 times more subsidies than the new renewable energy. We shouldn't be terribly surprised by this because oil and gas and nuclear power have been major contributors to the U.S. energy supply for a longer time than solar, wind, and geothermal. So that seems reasonable. The second thing that they found, though, and I'm going to skip this graphic for a minute and come back, maybe not. Okay, it's not listed on here, sorry. The second thing that they found was that oil and gas have received 13 times more subsidies, than new renewable energy sources. This is per year, so this is more significant. They saw that nuclear power has received over 9 times more support than the new renewable energy per year. And this is notable because it controls for the amount of time each source has been used and thereby shows that oil and gas and nuclear power have received far more support than solar, wind, and geothermal. Okay, so the third thing that they noticed was even in the earliest years of each energy source, when subsidies were the most useful for them, oil and gas and nuclear power received far more subsidy support than the new renewables have received. Only in one single year have solar, wind, and geothermal combined ever received as much support as the lowest amount ever offered for oil, gas, and nuclear power. So what these findings mean is that they corroborate the notion that new renewable energy sources have not received nearly the amount of support and subsidies and tax breaks that the longer established non-renewable energy sources have been able to enjoy and continue to enjoy. So what does this mean? It means that many feel that the subsidies, I don't like that word anymore, showered on fossil fuels have helped to enhance America's economy, and that the national security and international influence by establishing thriving global energy industries dominated by U.S. firms. So the U.S. firms are controlling these. By this logic, if America wants to be a global leader in the transition to clean and renewable energy, then what needs to happen is political and financial support will likely need to be redirected toward the new energy sources. And Barack Obama did cover this in his 2010 State of the Union speech, and he basically said that the nation that leads the clean energy economy will be the nation that leads the global economy. And the United States wants to be that nation, but will they be that nation? It remains to be seen. I'm going to ask you to please read the science behind the story on page 286 and 287. It's comparing the energy sources. Okay, so let's take a look at these graphs. The pie chart in A represents total subsidies, and the graph in B represents per year. So when we take a look at the total subsidies, we can see that oil and gas is receiving almost 75% of the support. And then when we look at our renewable energy sources, or our conventional energy sources that we have, our new renewables are really small. Far less is being spent in these areas. And again, if we look at per year, again, we're seeing that more oil and gas is getting the funding, and nuclear is pretty close, but our conventional and new renewables are only receiving a small amount of money for the subsidies. So what we're going to do is we're going to take a look at solar energy. And I think you're going to be just totally amazed. I don't think anybody ever really thought about this. The sun releases an astounding amount of energy that is converted by hydrogen and helium through a process of nuclear fusion. So the sun's capable of doing nuclear fusion. We're not, but the sun is. The tiny proportion of that energy that actually reaches the earth, and there's not a lot, is enough to drive the processes in the biosphere and make life possible on our planet. The earth receives enough solar energy to power human consumption for a quarter of a century. And this is just on a daily basis. That's not on a yearly basis, but every day. Each square meter of the Earth's surface receives about 1 kilowatt of solar energy. So if you're not sure what that means, that's 17 times the energy of a light bulb. That's how much is there. And again, that's on average, and we're looking at what happens on a day. So a typical home has enough roof area to meet all of its power needs with the rooftop panels that harness solar energy. But the problem is we are still in a process of developing solar technologies and learning the most effective and cost-efficient ways to put the sun's energy to use. So what we have available to us is not necessarily the most efficient way of using it. So we're going to look at two ways of collecting solar energy. One is going to be passive solar energy collection, and the other is going to be active solar energy collection. And of course, the simplest way to harness solar energy is through passive solar energy collection. And this is where buildings are designed to maximize the absorption of the sunlight in the wintertime. So what this means is that in order to keep their interior cool in the heat of summer or warm in winter, what they're going to do is they'll install south-facing windows, and this maximizes the capture of the winter sunlight so that it will help to warm the house. They will then put overhangs and shade windows in the summer when the sun is high in the sky and when cooling, not heating, is desired. So passive solar techniques also use materials that absorb heat and store it and release it later. And we call these products thermal mass. So they can be straw, they could be brick, they could be concrete, and they can be some other materials as well. And they often make up our floors and our roofs and our walls. And they can be used in portable blocks so that it's easy to transport and use. Plant vegetation will also be planted around the building to buffer the structure from temperature swings. That's another passive solar approach. And then passive solar approaches are an important component in sustainable buildings. And these methods help conserve and reduce the energy cost. Excuse me. Active solar energy collection makes use of devices to focus and move or store solar energy. And this is where they're going to use this technology to heat water and air in our homes and our businesses. One of the common methods, and the one I think we're most familiar with, is installing the flat plate solar collectors on rooftops. And what you may not know is these actually consist of dark colored heat absorbing metal plates that are mounted in a flat glass covered box. And they run water and air or antifreeze through tubes that pass through these collectors, and then they transfer that heat from the collectors to the buildings or to its water tank. The heated water can be stored for later use and then can be passed through the pipes designed to release heat into the building. There are about 200 million households worldwide that heat their water with solar collectors. 1.5 million of those are in the United States, and most of them use them for their swimming pools. Active solar heating is also more widely used in China and in Europe, and the Germans have motivated their people by feed-in tariffs and have installed about 200,000 new systems. That's the picture that we saw early on. And they have proven to be very useful in isolated locations. All right, so we're going to end this screencast here. I didn't advance the screen, but this talks about the flat plate solar collectors that we just spoke about. And then what we'll do is we'll start with this on the next screencast. So see you on the other side.